Good evening students. Today we will start complex number. So first write down it. Complex number. Anyone know about complex number? Okay, I can start from the beginning. Can anyone tell me the value of root over -9? Is this term defined? No, it is not defined, at least not in real number. In real number we cannot define negative under square root. But for this type of number, specifically complex number chapter arises. Because we cannot define negative number under a square root. But in complex number we can. In complex number we will define a term iota, which is represented as I and defined as I square equal to -1. Write it down. Okay, I square equal to -1. So now we can derive this term value. So root over -9, we can write it as -1 into 9. We can write -1 as I square into 9. So I square into 9 we can write as 3I whole square. So we can write it plus -3. So from the help of I, we have derived the value of root over -9 as plus -3. So this is the small definition of complex number. But complex number has a vast number of application. If anyone know about Ohm's law, in Ohm's law we can see the complex number use. I think in physics we will study later or already studied it. But it has number of application, vast number of application in different branches. In higher studies, in quantum physics, we use complex number. But we will study it in the term of mathematics, in the term of iota. So first write down power of I. Power of I. There is a pattern in I. In this pattern, we will start from I to the power 1. Okay? So I to the power 1 is I. I square, what is the value of I square? I square value is -1. Okay. What is the value of I cube? I cube value, we can write it as I square into I means -1 into I or -I. Okay. What is the value of I to the power 4? I to the power 4, we can write it as I square into I square. I square value is -1. So we can write as -1 square means 1. After that it will repeat the value. Means I to the power 5 will be 1. I to the power 6 will be -1. I to the power 7 will be -I. Any number of power I, if any power I to the power k, we can write it as a multiple of 4. There will be some remainder. So we can write I to the power k as 4n plus s, where s is the remainder. S can be 0, 1, 2, 3. Okay. So if I to the power 4n plus 1, then the value will be I. If it is I to the power 4n plus 2, value will be -1. If it is I to the power 4n plus 3, value will be -I. If it is I to the power 4n plus 4, value will be 1. Okay, understand? So derive one expression. Find the value of I to the power 37 plus I to the power 5. Derive this expression value using this formula. I to the power 37 plus I to the power 5. So what I have said, first express this integer in the multiple of 4 and there will be some remainder. So I to the power 4 into 9 plus 1, we can write 37 like this. This is I to the power 5, so we can write it as 4 into 1 plus 1, right? So now this is what? 4n plus 1. 4n plus 1 value is what? I. So this is I. This is also I. 4n plus 1. So this is 12. So our simplified value of this expression is 12. This is very easy. We can solve this type of question. I am giving a question for you guys to do. Find value of I to the power 45 plus I to the power minus 9. Okay? Do it in homework. Now we will see general form of complex number. So general form of complex number. Any complex number represented by Z. Okay. Any complex number, write it down. Any complex number is represented as Z equal to A plus I B. Okay. Where A is called the real part of Z and B is called imaginary part of Z. Where A equal to real part of Z and B is called imaginary part of Z. Okay. We can algebraically represent any complex number as A plus I, where A, B are real numbers and A is called real part of Z and B is called imaginary part of Z. Now, if in note, write it down. If any two complex numbers, Z1 equal to A plus IB and Z2 equal to C plus ID are equal, then A equal to C and B equal to D. So that means real part should be same, imaginary part should be same if they are equal complex numbers. Otherwise it cannot be equal. So all of you understand it? Okay. Now we'll get to the next topic. We can, like real numbers, we can do all the arithmetic operations on complex number. Addition, multiplication, division, all the operations we can do. So we will see it. We will get to the next topic, modulus and conjugate of complex number. Modulus and conjugate of complex number. we already know that we can represent every complex number as z equal to a plus ib. Here modulus is defined as modulus of z, modulus of z, write it down, is defined as mod z equal to root over a square plus b square. So here write let z equal to a plus ib. Okay. So modulus of z is defined as root over a square plus b square. In multiplication, we have already seen that one thing, that a plus ib into a minus ib. So after multiplication, what we are getting? A square minus ib whole square. So I square means minus 1, it is a square plus b square. So we have already seen that whenever we are multiplying a complex numbers, only changing this sign, positive to negative. If z is this, if we are taking minus in the middle of these two terms, then after multiplying we are getting a square plus b square. It is always true. And now you know about that a square plus b square is actually the modulus. Root over a square plus b square is the modulus. So what we can conclude from here, that a minus ib has a specific part. It has a importance. A minus ib, here a minus ib is actually conjugate of z. Is actually conjugate of z. But z is what? Z is a plus ib. So write it down. Conjugate of z is represented as z bar equal to z bar. Z at the top of z there will be a bar a minus ib, where z is a plus ib. So for any complex number you can derive the conjugate of z. For example, tell me z equal to 2 plus 7i. Tell me what is the conjugate of z? Yes, only the plus sign will be changed. It will be conjugate of z will be 2 minus 7i. Now tell me what is the modulus of z? Okay, modulus of z, our formula is root over a square plus b square. A square means here 4, b square means here 49. So it will be root over 53. Okay. Understand? Now we will get to the next important topic, how to geometrically represent a complex number. We have known some concepts, some terms algebraically, but geometrically we didn't introduce it. Now we will do it. How to represent complex number geometrically. So to geometrically represent complex number, we will introduce a new kind of plane, Argand plane. It is not new, but its name is new, you can say it. Argand plane. Argand plane is same like Cartesian plane, there is no difference, but Argand plane is specific to represent complex number as a point. You can represent every complex number as a point in the argand plane. So I have said that the argand plane is like Cartesian plane. So there will be vertical axis, there will be horizontal axis. Okay, this is horizontal axis. This is also called real axis. This is called real axis, or we can call it x-axis or x-axis, or we can say horizontal axis also. And this is called, vertical axis is called imaginary axis. This is called imaginary axis or y-axis. It is same like Cartesian plane. This is positive y, this is negative y. This is positive x, this is negative x. Okay. Like we have a complex number z equal to 2 plus 3i, z equal to minus 2 minus 3i. Now every z, for every z, like in general form, z is what? Z equal to a plus ib. We can write every z as also z equal to a comma b. Here it is in algebraic form, here it is in a point form, and a point can be represented in argand plane. So a comma b, here a comma b is what? 2 comma 3, right? So 2 comma 3, maybe it is 1, it is 2, okay? 2 comma 3 means x is 2, same like Cartesian plane, 1, 2, 3. So here will be the point 2 comma 3. So this complex number, let's say this is z1, this is z2, so this is z1, okay? This is our z1. Now what is z2? Z2 is minus 2 comma minus 3. So minus 2 means negative x, so minus 1 minus 2 comma minus 3, so also negative y, minus 1 minus 2 minus 3. So this will be the point of z2. Okay, so this is our z1, this is our z2. Any point, any complex number can be represented as a point in the argand plane. Okay, and its importance is that through this we can introduce another form which is called polar form of a complex number, because a plus ib is algebraic form of a complex number, and there is another form that is called polar form of a complex number. Okay, so polar form, also draw this down. Okay? So for polar form of complex number, for polar form of complex number we need two terms which are very important. First one is modulus. Modulus we already know about it. Modulus is root over a square plus b square, where z equal to a plus ib. There is another term that is called argument of complex number. Argument, or we can call it amplitude, or amplitude of complex number. Write down its definition first. You see, this is the point z1, and what is this point? This is origin. This is origin in Cartesian plane. In argand plane, this is also origin, 0, 0. Okay. So from origin to this point, draw a line. Okay. Joining these 2 points, we get a line segment. Now this line makes an angle with positive x-axis, only positive x-axis. Makes an angle with positive x-axis, and that is called theta. This theta is called argument. So write this down. The definition is the angle made by the line joining origin and the complex number with the positive x-axis. Okay. Angle made by the line joining origin and the complex number with the positive x-axis is called argument. Okay. Now, theta, the formula for theta is tan inverse b by a. Okay. Where obviously what is a and b? Where z equal to a plus ib. So you know a complex number in algebraic form, you can derive the angle theta. And after deriving theta, we can represent it, we can transform it in polar form. So first we have to derive the argument. Okay. Now for argument, for do the calculation easily, we can introduce some formula you have to remember so that you don't mistake anywhere. Because here, like Cartesian plane, there are in Argand plane there are 4 quadrants: first, second, third, fourth. Now your point can be in any quadrant. It can be here, it can be here, it can be here, it can be here. And for that, your argument will also change because your theta is only making angle with the positive x-axis. Okay. So remember it. In note write it. How to derive the argument? First derive theta equal to tan inverse mod b by a. Okay. We will not take any sign of b a, just tan inverse mod b by a, taking positive sign. First we will get the angle. Then we will see कि a comma b, if a comma b is in, now write it, if it is in first quadrant, okay, first quadrant, then theta will be tan inverse mod b by a, nothing will change. Okay. If it is in second quadrant, if it is in second quadrant, then it will be theta equal to pi minus tan inverse mod b by a. Okay. If it is in third quadrant, the theta will be minus pi minus tan inverse mod b by a. Okay. If it is in fourth quadrant, it will be theta equal to minus tan inverse mod b by a. Because it will be easy, very easy in calculation. When you will do the calculation, you can see. First, whenever a complex number given, you will see, first you will derive this value, tan inverse mod b by a. First derive this value. Then you will see whether the complex number is in first quadrant, second quadrant, or third quadrant, or fourth quadrant. According to this, you will use any one of these formula. Okay. And now see one question. In the argument of z equal to minus 1 minus root 3i. Now what I have said that first what you will do, first we will see what is a here. A is minus 1 and what is b? B is minus root 3. So what will be the tan inverse mod b by a? It will be tan inverse mod b by a means minus root 3 by minus 1. Okay. So basically this is tan inverse root 3. What is the value of tan inverse root 3? Right? Pi by 3. Now see, A comma B is in which quadrant? Minus 1, minus 4, 3. Means x is minus, y also is minus. That means it is in third quadrant. Is in third quadrant. Okay. So in third quadrant, what is our theta formula? Our theta formula is minus pi minus this, right? So this is what, pi by 3. So this is minus 3 by minus pi, 3 by 3. So our argument value is, for this complex number is minus 2 pi by 3, right?